Hey folks, welcome to a little video on parallel and perpendicular lines, alright? So in this video, I'm going to talk to you a little bit about what is parallel, what is perpendicular, talk about some of the things that you'll see when looking at parallel and perpendicular lines, and then we'll talk about how do we write equations for parallel and perpendicular lines so that we can have a line that's either parallel and or perpendicular to a line and that passes through a specific point. Okay, so maybe you've learned about parallel lines and perpendicular lines in the past, but here's what we know. Parallel lines, all right, you might have learned are lines that never cross or never touch, all right? And another way to look at this is lines that have the same slope and different y-intercepts. So here's an example. Here's two equations written in slope-intercept form. Y equals 2x plus 1 and y equals 2x minus 3. We can see that their m values, which represent the slope, are exactly the same, and their y-intercepts, 1 and negative 3, are different. And because these start in different places and have the same exact rate of change, they're never going to touch each other. Think of it like this almost. If you and your friend, right, start having a race, your friend starts ahead of you, and you start behind them, and you guys run at the same pace, you guys are never going to catch up, right? That's because you've already started behind or your friend has started behind. And if you go at the same pace, right, you guys are never going to meet because you'll always be going one after another, okay? If you've ever driven in a car before on the road, maybe, here's another example. If you start behind someone else and you're driving at the same speed as them, they're never going to catch up to you, okay? So that's a little example of parallel. Okay, on the other hand, we have what are called perpendicular lines. And perpendicular lines are lines that meet at a special angle, right? A 90-degree angle, which we signify with a box, all right? And perpendicular lines have what we call opposite reciprocal slopes. Okay, so here's my example. So I have y equals negative 1/2 x plus 8 and y equals 2x plus 1. Okay, and we can see that these have opposite reciprocal slopes, and here's why. Because if I take 2 and I turn it into a negative, it becomes negative 2. And then if I take the reciprocal of negative 2, I get negative 1/2. All right? So these are our two special types of lines. Lines that are parallel and lines that are perpendicular. Okay? And these are two very special types of relationships that you can have with lines. So here's what I'm going to do. I'm going to take a second and talk to you about opposite reciprocals. What are opposite reciprocals and how do we find them? Okay, so when we think of an opposite means when we flip the sign of a number. Okay, and sometimes mathematicians will refer to this as an additive inverse, a number that when added to another number gives you 0. For example, if I have the number 1, okay, the opposite of 1 is negative 1, right? You can see that the difference here is the signs have flipped, but if I take these two numbers and add them to each other, what I get is 0, all right? Those are opposites. On the other hand, reciprocal is when you flip the numerator and denominator, okay? And mathematicians will call that a multiplicative inverse, right? Because when you have a number, let's say, I don't know, 3, right? And 3 is actually, when we think about it, because 3 is a whole number, it's really 3 over 1. And when we take 3 over 1 and multiply it by its reciprocal, its multiplicative inverse, 1/3, what do we get? Well, we get 1, okay? So that's what we mean by a reciprocal and an opposite. And now what I'm going to do is I'm going to put those together and get an opposite reciprocal. So not only is it we start by getting the opposite, but then we start by getting we then get the reciprocal. And it doesn't matter what order you do it. You could get the reciprocal first and then get the opposite, or you get the opposite first and then get its reciprocal. Okay, so I'm going to do 3 little examples for you, and then I'm going to have you try. Okay, so we have 3 examples. We have 2. We have 1/2. We have negative 3/2. Okay, so let me start with 2, and I'm going to actually show you both ways we could get its opposite reciprocal. The first way we could do it is we could start by finding its opposite, and the opposite of 2 is negative 2, right? It's like 2, but I flipped the sign. And then I could get the reciprocal of 2. or rather of negative 2. And negative 2 is the same thing as negative 2 over 1. So its reciprocal is negative 1 over 2, okay? Because what I've done is I've taken the numerator and the denominator and I flipped them around. Okay, alternatively, we could have done it like this. So knowing that 2 is 2 over 1, I could start by finding the reciprocal, right? Which is 1 over 2. And again, observe that if I take 2 and I multiply it by 1/2, what I get is 1, right? So that's another way to know it's a reciprocal. And now I can get the opposite of 1/2, and that's negative 1/2, okay? So if I need to find the opposite reciprocal of 2, here was how I do it. And observe, if we come back and look, we can see 2 and 1/2 are my opposite reciprocal slopes. And what's cool is it doesn't even matter what the y-intercept are. As long as we have opposite reciprocal slopes, the lines will meet at a 90-degree angle at some point in time. Because remember, we know that lines go on forever, right? So to say exactly where they meet, well, this is in the middle, but there really is no middle to a line, right? There's no really such notion because of the fact that they go on forever. Okay, now let's take a look at 1/2, all right? Now, how can we get the reciprocal, rather the opposite reciprocal of 1/2? So again, two ways to do it. First, I could start by getting the opposite of 1/2, which we know is negative 1/2. And then what I could do is I could get the reciprocal. And the reciprocal of negative 1/2 is negative 2 over 1, which is the same thing as negative 2. Okay, alternatively, I could start by getting the reciprocal. So I could start by flipping the 1 over 2 to get a 2 over 1, which is the same thing as 2. And then I could go and find the opposite, which is negative 2. Okay, so two different ways you could do this one. Finally, I'm going to do 3/2, or rather negative 3/2. So I'll do it just one way. If it starts as a negative, when I flip it, it will become, or rather when I get the opposite, it will become a positive. And then when I take its reciprocal, it will become 2/3. Okay, so go ahead and take a second. If you need to go back and rewind and take a look at how I did this, go ahead. But here's what I'm going to do. I'm going to ask you to do 3 questions. I need you to find the opposite reciprocal of negative 6, of 2/5, and 5/7. Okay, so pause the video, try to find the reciprocal, and then I'm going to show you how to do it. And we're looking for the opposite reciprocal. All right, here we go. Opposite reciprocal of negative 6. So negative 6, what I'm going to do is this. I'm going to go ahead and I'm going to get the opposite, which is 6, and I'm going to get the reciprocal, which is 1/6. Alternatively, you could have started by taking the reciprocal, which is negative 1/6, and then finding its opposite, which is 1/6. Okay, so two ways to do it, but the answer you want to get in the end is 1/6. How about 2/5? Well, first we could flip it and get the reciprocal, which is 5/2, and then we could take its opposite, which is negative 5/2, or we could start by getting its opposite, which is negative 2/5, and then taking the reciprocal of that, which is negative 5/2. And just so you know, folks, when you have a fraction, it doesn't matter where you put the negative. You could put the negative on top, which is usually what we prefer if you're going to put it between the top or the bottom. You could technically put it on the bottom, or you could put it off to the side, okay? Because what we know is a positive divided by a negative, well, that's always going to be a negative number, okay? So I'll kind of be lenient, but here's the thing. I would rather you put a negative in the numerator or off to the side. And I'll show you what that looks like, because 5/7, what we should get is we have our reciprocal, and then we have our opposite. So here's another way to write it with the negative going in front of the number. Okay, so take a second, and again, if you need to go back and do the explanation, go ahead and do that, and then I'm going to turn to the next part. Okay, so now we need to do some equations. So find the equation of a line that's parallel to y equals 3x minus 2 and passes through 6, 5. Okay, so we need a line that's parallel, so we know the slope has to be the same as the slope of this line. And what's the slope of this line? Well, it's in slope-intercept form, so we know that the slope is 3. Now, do we know an equation that will let us figure out a line with a slope that passes through a particular point? Of course, we know what we call point slope form. Right now, this is the way I taught it in class, and there's a couple different ways to do it. We could do y minus k equals m x minus h, where hk is the point that the line passes through, and m is the slope. Sometimes you might see k written as y1 and h written as x1, and the letters that you call it don't matter. I like to do it again because I don't like the y1 and the x1 to get confused with the y and the x, but how you do it is your choice. So let's take a second and think about it. The slope of the line needs to be 3 so that it will be parallel. The line needs to pass through 6, 5. So the x-coordinate of the point has to be 6, and the y-coordinate has to be 5. So let's go ahead and plug that in. So we have to have x minus 6, so it will pass through x is 6. And then we have to have y minus 5, okay? And now that will ensure the coordinate on the point on the line is 6, 5, and the slope is 3. And therefore, because the slopes are the same, these two lines will be parallel. Okay, so go ahead if you need to, take a second to rewind that, and then I'll move on to the next one. Okay, so now we want to find the equation of a line that is perpendicular to y equals 1/2 x minus 4 and passes through negative 2/3. So again, I'll go ahead and identify my key information. Okay, here's my h and my k. And now again, I'll use point slope form. So first, notice the slope of the original line is 1/2. So I need to get the opposite reciprocal of 1/2. So I start by taking 1/2, I make it negative 1/2. That's the opposite. And then I make it negative 2/1. That's the reciprocal. So the slope that I want for my line is negative 2. And since we want to go through the point negative 2, 3, we write y minus 3 equals negative 2 times x, and be careful, this is a negative 2, so we want it to be plus 2. So we have y minus 3 equals negative 2 times x plus 2. Okay, so again, take a second, rewind if you need it, and then here's what we're going to do. I'm going to ask you to try this one. So find the equation of a line that is parallel to 3/5 x plus 7 and passes through 1738. Pause the video and try to figure it out, and then I'll show you how to solve. All right, here we go. So I'll show you how to do this one. Again, here's our line, 3/5 x plus 7. The slope of our new line has to be 3/5 so that it will pass through, or rather be parallel to this line. And the point we want is 1738. So I have to have y minus 38 equals 3/5 x minus 17. And using point slope form helps us a lot. There's no b to solve for. There's none of that. All you have to do is find your slope, plug in your point, use point slope, and you're done. And that's one of the really good reasons why I really emphasize point slope form, is because it makes your life so much easier when it comes to these questions. Okay, last question for you to try. Find the equation of a line that is perpendicular to y equals negative 3/5 x minus 2/5 and passes through negative 1/2 2/3. Okay, so again, pause the video, try to solve, and then I'll show you how to do it. Okay, so again, we have our line here, and the slope of our line is negative 3/5. So I need to get the opposite reciprocal. So the opposite, how about the reciprocal first? The reciprocal is negative 5/3. The opposite is positive 5/3. So this is going to be the slope of the line, and we want it to go through negative 1/2, 2/3. So I have y minus 2/3 is equal to 5/3 x plus 1/2. And remember, because we're in point slope form, it's okay to have fractions. That's completely fine. We are allowed to have those. Okay, so I hope you enjoyed this video. I hope you found it as a good starting place. Okay, so I want you to go ahead, make sure you understand this video, rewind if necessary, and then I want you to try some of the practice problems that I've put out there so you can make sure you really understand this concept, all right? I have a lot of faith in you, and that's why I'm putting a lot on you to make sure you understand this. Don't forget, you can do it. All right, best of luck, folks. Keep at it. I know you can do it. Have a wonderful day.